Hey everybody, happy Friday. Hope you had a good week. I did. I'm glad it's Friday though. I'm glad it's the weekend finally. Today, what I want to do is go ahead and model some of the servo motors that I know that I'm going to eventually use. I've got a very slow stepper as well. These are really common, cheap parts, but I figure that they'll be useful at some point. Additionally, I've been trying to think of a way that I can build a mod where I can spin a pop bumper cap every time it fires. I want to do this with minimal invasion, if possible, and no permanent damage to the table. So I don't know if we have time later, we can start going through that and just thinking up some ideas. But in the meantime, I guess let's get started modeling. It has been a long week. I'll tell you what, been busy. All right, what are we gonna do? Large servo, large hobby servo. So for anybody who doesn't know, these are servo motors are the motors that will go to a specific position rather than turning indefinitely. There are a couple of different kinds. There are the most common kind for the um, hobby trains and their cars and boats and stuff are the kind that have some sort of a sweep that's usually around 180 degrees, so it can go one way or 180 degrees the other way and any sweep in between. And the thing about servos is you can tell it exactly where you want it to go within that arc, and it'll move to that. There are also servo motors that are 360-degree continuous. I've never had one of those, so I'm not exactly sure how they respond to the input signal. Um, at some point, I'm going to take some of the smaller ones here and uh, modify them so that they are 360-degree continuous. But at that point, I can only give it a speed that I wanted to run at. Hey, Toyota boy, good to see you again. It'd be interesting to use a NEMA motor and a pinball, but it's a lot heavier in the hobby servo. That is true. The reason why I'm doing these specifically, I have a ton of NEMA motors, and McMaster Carr has a pretty extensive catalog of NEMA motors since they're standard anyway. Uh, the reason why I want to go ahead and do these servos is because this one I just happen to have. These small ones are the ones that I expect that I'll use first, because this one will fit in a pop bumper cap. And since I'm thinking about doing that mod, I figured that was a good place to start. How was your week? Did you do anything interesting? You got any plans for the weekend? I also have to figure out if this is likely to be metric or imperial. Too close to tell. That might just be thermal expansion in the molding. Oh, that's pretty close. 55. Okay. We'll say that they're metric. They likely are anyway. All right. So 40. Oh, but we're in inches, which is the normal thing to do in pinball, but not today. Millimeters. There we go. All right. 3 and 20. Yeah. Okay. I'm convinced. Now, my guess is the shaft is going to be 10 in from both sides. Let's see. Hobby servos are really cheap too, especially on websites like Hobby King. That is absolutely correct. And cheap is generally good. You can get some that that have metal gears, which is what I recommend, because they're less likely to strip. Although if you get enough power behind it, like a coil or something, they'll absolutely destroy these things. I'm really not even sure what the difference is between the super cheap ones and the really expensive ones, because they all have the same form factor, and I'm sure there's something. Maybe it's just torque, but uh, you can get servos like this for a couple of bucks a piece, all the way up to $90, $100. But I don't really know the difference, other than maybe um, um, how rugged they are. Okay. 15. Well, another thing I was thinking about doing tonight that I don't think that we'll get to. I don't know, we might. We'll see how it goes. Was I would like to sort of challenge myself and everybody else who wants to participate in trying to come up with a design with zero ramps. A couple of reasons for that. One, it seems like it would be challenging, and two, it's much more likely that I would cut one. Um, so if it looked like it might be fun, we could actually cut it out and see if it is. Bigger price equals more torque, more speed, or both. That makes sense. TNA has tons of ramps. They're all invisible. Yeah, it would seem. Are you just talking about the scoops, or did you have something else in mind? TNA does a great job of doing the layout, I think. And that's part of the reason why I want to check that out. That's the joke, yeah. Um, they Scott did a great job of using the space, and it feels intuitive. And then that center area that's got, the inner flipper feels like it's a upper or lower play field. It's really good, in my opinion. Well, in tons of people's opinions, because um, it's highly regarded everywhere. I still have yet to play a TNA, and I'd really like to do that at some point. How tall is this? It's 2 millimeters. Off the shelf parts, except the wire form along the back. Uh, what's I? I guess I haven't seen it up front. What is the wire form in the back? Let's see where we want to go. Nah, that's not what I wanted. There's this. How wide is our actual shaft here? 6 millimeters with teeth. Oh, we can get rid of that for now. That's like the old school early 80s curved rod for a while. Okay, I got you. Yeah, most of the that's basically what my options are. I bought some uh, sheet metal to make ramps and stuff. Or not ramps, rather rails. Uh, in my Amazon cart, eventually I'm going to go ahead and get this combination metal shear, brake, and roller, so that I can start, making those for real. But in the meantime, as my homebrew right now just has the Italian bottom on it and nothing else. I've got a rail just sort of taped in place for playing around with. But at some point, I'm going to have to start making those with some amount of precision. And that'll be nice to do. But everything else is just whatever was cheapest on Pinball Life or Marco at the time. Hot glue cardboard to test your walls. Don't go straight to metal. I won't. I actually have a lot of foam core, which if you guys watch Ben Heck, he's got a lot of good resources on doing that kind of stuff, and that's what he does. Alright, let's finish this up. Kind of dragging today. I've been doing this a lot. There we go. Let's figure out how tall we are here. Well, use the Imperial one. 6 millimeters. And then here, let's see, how are we going to do this? Let's make a loft. And go from there to there. Why don't you like that? Because of course you don't. Alright, let's see. Can we do it? Oh, you know what? That might actually have to be in a sketch. Let's see. Oh, but we can't see the geometry in the second one. Oh, maybe we'll just do that. Okay, project it. Okay, foam core isn't as smooth as you bend it, though it works pretty decently enough. Yeah, that makes sense. Really, I haven't gotten to that stage yet. Honestly, most of my my design work has just been here in Fusion. I think it was either you or somebody had suggested that I go ahead and take a look at using VPX to build it and try it out. And I still intend to do that at some point, but there's a pretty steep learning curve associated with that, I think. Why can I not do this loft? All right, you know what? We're just gonna do it the jank way. Okay, we have our body. Let's do this, include that with it, and just throw a chamfer on it with 2 distances. Oh, okay, 1 distance. I guess that works. All right, that's what I wanted. Now we got to figure out. Oh, you know what? Shoot. We'll just move it later. That's fine. I was just thinking here that I need to put the origin of this thing to something that makes sense. But what makes sense? I'm not sure what makes sense. Either right where the shaft is or where it ends, so that it signifies the arm, or on the same plane as the mounting screws. I don't know. I suppose I can change it later, so it doesn't super matter. Okay, now we need to do an offset plane here. Let's see, what is that? 7 millimeters. Okay. Project our top geometry so that we've got lines that we can work with. Now we want that, and these are going to be straight. And we have holes, and they're symmetric, and the other side is also symmetric. So we'll do this, and then give ourselves a line right there in the middle to mirror everything. All right, let's see. What are we looking at? We'll call it 5.5. It's actually a hair over, but that's okay. And how deep? Boy, these are weird measurements now. Did we suddenly switch to Imperial? That is a weird thing that happens with parts that have been around for a while. Well, that's closer, actually. Nah, that's still oddly fractional. Okay. 7.3. It's so strange. Okay, and see how far back these are set. Call it 3. Yeah, that'll work. Well, surely that's not right. That's way too small of an edge there. 4.5. 4.5. Okay, that makes more sense. There we go. Okay, we're gonna want to mirror this here at the distance between these two. $10mm. Usually when you find something that's about that right, or that when you find something that makes numeric sense, then that's usually right. How wide is this? Is this not the same? That is 18 on the dot. This whole pattern doesn't look correctly. Oh, okay. Well, there's your problem. Let's get rid of these. Why can I not delete these lines? It's not letting me delete anything. This is bizarre. Find some... Oh. That is bizarre. Okay, well, let's try this again. Oh, it might have just been because I had the other sketch turned on at all. Okay, this, we want it to be 18, and then we can throw... Oops. Let's see. 7.3. So this mod idea about the spinning pop bumper, I'm not exactly sure how I'm going to do that. But I do think that it would be really kick-ass and would work on just about any pinball table. And I'm a little skeptical because I would have expected somebody to have done it by now. So there must be some reason that it's super difficult to do. Oh, we need to mirror that first. Actually, yeah, instead of mirroring the sketch geometry, let's just mirror the part. 2.5. 2.5. Okay, and now we'll mirror that thing on the other side. We want to mirror feature, that guy, mirror plane. Oh, we don't have a mirror plane there. All right, fine, I'll do it this way. Select that, and that, and that, and mirror it on that line. Finish that up, modify this extrusion to be that as well. Good. Okay, let's go ahead and put our fillets on this so that it looks nice. Oh. Not that one, that one. And I have no idea what that radius is, but it doesn't super matter. Yeah, it's close enough. Okay, what else do we need to do on this? I do want to round it over a little bit, but I mean, that's basically it. I suppose I ought to go ahead and model in the cord here, because that can get in the way. Let's fillet all of these faces. I think this is what I need to do. Yep, that's nice. And I didn't realize that I had that hole in the bottom. Let's find that extrusion. Yep. And do all of these. There we go. Okay, well, it's looking like a servo. Let's go in here. I would imagine that this is offset by the amount of the fillet, and in our case it is. And what are we looking at? 4 and 6 and a half. 4 and 6 and a half. Whoops. 6.5 and 4, and give ourselves a construction line. We'll project this first. There in the middle. Okay, and we're going to want to put a point. Yaw. Throw that on there, and I guess make this linear with that. Okay, let's see how deep it is. I mean, the wire comes out of this, so it doesn't really matter what the plastic housing is. But just for completeness, extrude this. Whoops, 2 millimeters. And let's round that as well. Actually has curves on both sides, it looks like. No, you're not going to let me do the bottom here, are you? Okay, alright. That's probably good enough. I could model the wire and try to guess at about how extreme an angle you could bend this, but this is probably fine. Let's see. For that guy, let's do a new body instead of joining it so that we can give it a different appearance. Let's see, I think that's a 2 millimeter shaft in there. I don't know if it's better to... This is probably fine. I'm sitting here debating whether or not I should model this as a shaft with the actual tooth gear on it, or just leave it as is. I think I'll go as is. And let's just give this black matte plastic. And just to differentiate the gear itself, we'll make that gray. Okay, cool. Well, one down. Move on to the next one, I suppose. Okay, so this is basically going to be the same thing. Let me put this back together. This is basically going to be the same thing with smaller dimensions, but this is the one that I actually want to do because it's more likely the one that I'm going to use next, or at least try to use next. Okay, let's take off the arm. All of these different arms, these arms have a lot of different variants that you can put on there. Most of them are pretty simple, like this, but there are also discs and pluses and crosses and all sorts of different shapes that I guess are useful in various applications and RC planes and stuff. So what is this? This is a micro hobby servo. Oh, that was one of the things that I forgot in the large one. Let's go ahead and reposition this while we can, or while I'm thinking of it, because otherwise I will absolutely forget. I guess the best place to put this is going to be at the bottom of the arm. Again, it probably doesn't matter all that much, but yeah, so we're pretty close anyway. Go ahead and take all of these. I think we can just move this up by 2. Or, wait. Did I need to go down? Yeah. Yeah, okay. So, yeah, that puts the origin right there where the shaft is. That's what we want. Okay, cool. Cool. Moving on. All right, this time I think I will take the opposite approach and go ahead and model the mounting spots first. Let's see, so we're looking at 12 and 30, 1, 2 and a half. Oh, but we're back in millimeters. Or, sorry, we're back in inches. We should be back in millimeters for these. And I forgot what I said. 32 and a half and 12. And again, oh, yeah, let's see. 20, 22 and a half for this inner box bit. So we want that centered. This was probably not the best way of doing this. Break that in both of those places and make them equal. There. Okay. Yep. That's what we want. All right. Let's just start with that and extrude it out. Oh, we should probably put in these tabs as well. These are odd shaped. We're going to want to mirror this in just a second. We'll put in our thing. These are in the center, though. All right. How big are these? Not very. 2. And they appear to be centered. I always hate it when there's something that you have to measure and it's in exactly the wrong place to do it. That looks half-ish. It's also 2. How far is this? If it's in the middle, that would make me happy. It's not, but... Okay, and then these also have this little tiny tab part. Jeez, that's small. And it's 1. Okay, that makes sense. So we want that, and we'll mirror it around this. And, oops. Nope. No. Okay. And put those at 1. Okay, so now we can take that whole thing and mirror it on here. Finish that. Okay, cool. So tab is 2.4. Go ahead and do that 2. And how tall is this thing? 16, 17, 18. 18. Show this again. Okay, so that's the bottom. Let's see how big this shelf is. 5.5. All right, now we can start on the actual shaft part of this. You know what? Let me put this at this other sketch origin. It's something sane, like dead center. Where's my center line? There it is. Okay. All right, so what are we looking at here? 1, 2 circles plus a keyhole type of feature thingy. 11.5 and 4.6. I hate putting in stuff like that. All right. Project this, give us a center line. .6, and what did I say? 11.5. Yep. That's not 11.5. 11.5. There. Okay. Now we have to figure out how far offset it is. And there is not a good spot to register this with. Let's see. That's 5.5. That's got to be pretty close. All right, it's kind of like the other one, I guess. Let's do that line, and then let's break this one. Where's my break? Oh, well. All right, let's just do it. Let's just measure it. Jeez. It's 6 millimeters, so let's just put this in 6 as well. That looks right. Okay, and then this thing. 5.75. It doesn't super matter where this is, I don't think. It looks like it is nearly tangent. What? That's not right. There. Okay. Did this get... Oh, this got all messed up. Okay, and this basically looks like the shaft of one of the stacks of gears that's in here is basically tangent to this. Oh, you know what? I can actually measure this across instead and do it correctly. What is that? 14 and a half. Oh, we're gonna need some vertical lines. Another line, and make those tangent to these circles. Whoops, and also make them up and down vertical. Okay, this one tangent to here, and what did I say? 14.5, I think. I did. Okay. All right, those are nearly in the right place. There's a little bit of a fillet there. So, want that, and another line here. Oh, I don't know what happened there. Okay. All of that just for this. All right, 4.5. There's that, and reach over, figure out how tall the shaft is. 7 total. So is this really 2.5 on the nose? Okay. Let's make that another body though. All right, good stuff. We're getting there. So what? We just have the cord, and on these, there's no little divot that comes out of it. We'll make a divot though. We'll make it. And we'll pretend like the cord is, or we'll model part of the cord, I guess is what I'm trying to say. This is a lot of lines. Should have thought about this before I modeled that tab. Oh, that's a little jank. Let's see, can we do 0.5? That's better, I guess. Live with that. You gonna let me do? Oh, you are gonna let me do that. Nice. Okay. There. Now it looks injected molded for sure. Let's go ahead and do these as well. Okay. Well, I'm going to go ahead and make this thing blue because that's what I've got. And we'll use the matte gray for the shaft again too. What else was I going to do? The cord. And let's see. Okay, we're looking at 1 millimeter by, what is this, 3, 4, 3, 3. 1 by 3, we want to center it on this thing. And now, let's figure out how far up here to put it. 5. Oh, that's 5 from... where did I... That's 5 from the very bottom, so let's project that too. Yep. It's in an odd place. That can't be right. And yet it is. Okay, well. 3. This doesn't really matter. It's the cord itself. And in fact, let me color that differently. Let's make it glossy yellow. Why not? Okay. All right. Well, that should be ready to go next time we need to use it. Or the first time we need to use it. Okay. Now, the last thing that I'm going to model tonight, I guess, is this stepper motor. That's also pretty simple, but this particular one seems to be just absolutely ubiquitous everywhere. That it's super cheap. It has a 64-to-1 gear ratio, and I've only been able to drive it at maybe a half a revolution a minute, or I mean a second. So it's pretty slow, but I figured that it would be, useful for just having spinning play toys or whatever else. So because I have it, we're going to go ahead and do it. Okay. What are we looking at? A cylinder with tabs and that thing sticking out. Plus the shaft, and okay, well, let's go ahead and save this. Stepper motor 28BYJ 48. Fairly certain that's what pops up. Let's see. Yeah. Okay. Yep, that's the one. Okay. So again, this would be probably pretty helpful to do this where shaft is. And it is oddly, well, I mean, it's not even odd. It's not centered because there's a whole gearbox in this thing. So we're looking at 9mm. We're in inches again. Let's not be in inches. Nine millimeters. This whole body is 2678.1. 0.2. Okay. .2. All right. Now what's going to be really fun is trying to figure out how eccentric this is. Because it's like that, pretty much. How big is this shaft? 5mm. Now we're also going to have the tabs. So I want this as a guide. And looking at 7mm. We're going to want one of those and a mirror of that. Aw. And then an arc tangent. There we go. You can figure out how tall this is off of, where are we measuring from? The center? Oh, well, that would be half of whatever the total distance is, wouldn't it? Just 42, so 21. Can I pop that on there? Sort of. Oh, yeah, I guess that did work. Good. .21. Oh, and I didn't measure how. Okay, that was looking not correct, but I haven't actually dimensioned this yet. So yeah, that's much better. And I'm assuming that these mounting holes, which are 4.1, I guess, that is a weird number to have in millimeters. 4.1. Well, that looks right. Okay, let's copy these and mirror them about here. And now we've also got one of these doodads. I guess to keep this centered, what I want to do is mirror this guy. Okay. Good. The overall of everything here is 31.25. We're going to need a tangent. That's real close. Cool. Now I just got to figure out where exactly the shaft is in relation to the center. I see that there is a punch out for an axle on the inside of this thing. I am almost 100% sure that that's dead center in this assembly. So if this is 9mm, halfway is 4.5. So it would be what are we looking at? 11, 12 and a half minus 4.5 is 8. Math is fun. 8. We did it. We did it. Thank God. All right, let's figure out how big this is too. Forgot. Call it 14 3/4. All right, I think that's the whole thing. Luckily, this is going to go pretty quickly, I guess. Now we just got to extrude everything out. And that is 1.75. There's sketch up and going again. And this inner thing is 111.75. Looks about right. That's brass, though. So we'll go new body with it. Actually, let me hide that for now. Because otherwise the rest of this is going to join up with it as we do this. See, the tabs are a millimeter. The entire body is 19.25. That, and tabs, -1. Cool. And that doesn't go all the way down. It goes to, what is that, 17. And we want to do a new body, because that thing's blue. Okay. No, I didn't want to do that whole thing. Whoops. That one. Yep. And let's find some lovely brass. Matte brass. That'll work. Okay. Well, all of this is bent over. Let's church this up just slightly. Oh, and once again, where is that extrusion for everything? I forgot the rest of this. Okay, much better. All right, and this thing, I guess those are just fillets. It's got a little bit of shape to it, but I'm not going to bother doing too much. Okay, and for completeness sake, let's see, we want to need to do a cutout on this thing. Just a tangent plane would work anywhere, doesn't really matter. Project cylinder, give us our center line. And let's see, we just want to, how do we project? Oh, well, we can do it this way. Okay. Start line all the way down. Okay. Nope, we don't want it right in the center. We want to do one of those. Total width on this is 3. Depth is 6. Mirror this on there and make those 3. Whoops. we go. Okay. There. That's what we want. Okay, and there's our stepper. Great success. Let's go ahead and model where the wires are coming out, though. So I did that for the rest of them. I think we're probably looking at 1 again. We are. And 6. Okay, figure out how far off we are. It looks like 2. 2 1/4. Let's see, do we have that as a reference point? Nope. Now we do. Okay. I'll give that a new body so that we can also make that gaudy yellow plastic. Okay, well, that'll work for what we need it for eventually, I'm sure. And if not, we can revisit it. Okay, well, that's good for modeling, I guess. So the other thing that I wanted to take a look at today was the possibility of building a mod that I could put on pop bumpers that every time they pop, the pop bumper cap or something that looks like it on top rotates by some amount. And I was hoping that the servo would actually fit inside of the pop bumper body. So just for fun, let's figure out if that's going to be a thing. You know what? Let me do this. Let me go to. Do I not have an experiments? I do not. Okay, let's do a new one. Spinning bumper cap. And let's go get a pop bumper and throw it in here. We really only need the top assembly, but that's all right. Wait a minute, do I have a top assembly made? I might do. No, but it doesn't have the cap. All right, whatever. We need to stay within the constraints of how pop bumpers work anyway, so that's fine. Let's go ahead and ground the bracket as well. Ground. There. Now we get, this should, yeah, okay. It's actuated. Okay, and the cap. There's the cap. Why can't I find it? There it is. Okay, so this is what I wanted to figure out. Whether or not I can take one of these and shove it into a pop bumper. It is not looking like that's going to fit. Huh, okay. Well, because remember, there's also, yeah, that might work. Let's see. There's not a whole lot of room for anything in a standard pop bumper. You are absolutely correct. Additionally, you have the lamp in here, which I am unfortunately aware of. That's interesting, though. This would have to go like 2 degrees, maybe 3. Some older ones might have a longer body, but still not large enough. Yeah, I've also noticed with some of the parts that I got, uh, I'm. Can we take a second to talk about how amazing this pop bumper design is? Because it's basically unchanged for the last 70 years. Uh, they did this once, and then there's been like, sure, you can have the thumper bumper bodies, which is kind of nice because you didn't have to, it'd all just be one assembly, and you could pre-assemble them rather than having to do it when you put them on the playfield. But this basic design of having the spoon switch and its skirt, and then you know pulling down on this thing to make the ball fly out. This has basically been the same forever, and I'm super impressed by that because yeah, don't fix what isn't broke. That's absolutely true. It just it's so rare, I think, that you kind of get it on your first try or near that. This is the equivalent of that, I think. Okay, so that's clearly not not going to work at all. Oh, the easy thing would have been for me to just take my hobby servo and just throw it into the pop bumper body, but I need these anyway for something eventually, I'm sure. You might find a micro servo. I saw some of those. The cheapest one that I could find on Amazon was about 12 or 15 bucks. It was something like that. And then I started thinking about, with that size, what kind of torque are we going to get out of it? And the answer is almost assuredly not much. Um, and given that where it would be sitting in this, I guess, in theory, it's not subject to a whole lot of force because of this, but it's going to be jostled at the very least. I don't know. I'll put it this way: I didn't have a whole lot of confidence in it working, and certainly not $15 worth of confidence. Um, so I might at some point, but uh, let's see, how big are those? I saw pictures of them, or they're basically the size of your finger. The one thing that I did go ahead and order are some micro stepper motors that apparently are used in cameras, and they were 8 millimeters in diameter, which is I'm doing this like that's any point of reference. Let's see, what is 8 millimeters? All right, so they're a little bit bigger than a quarter inch wide, and I've been thinking about this quite a bit. If I put a tiny little servo motor in here, and then built basically an inner spur gear, and then put a gear on the servo motor, mounted the servo motor directly to the body, and then had a bearing or something in the center that would let the cap spin freely otherwise. And the servo motor could just advance whenever we wanted it to, and move the cap. You could also just have it spin forever or whatever. So that's still a possibility. I guess I can go ahead and give up on the hobby servo idea. I don't have this thing, so we'll have to model it some other time. But let's go ahead and make one, I guess. That's about, actually, let me, off screen, let me go ahead and pull up that order so that I can actually look at the dimensions of this thing. And they will be here tomorrow. 8 millimeters by 8.2 millimeters. And then there's there's a gear with an outer diameter of 2.2. That is incredibly small. Okay, so basically we are looking at 8 millimeters, 8.2 millimeters. So that, and to put that in context, that's that big. Okay, so that that might be doable. Because you could put that all just about anywhere. Interesting. Alright, so that's a possibility. And what is this? They're driven on, okay, basically 5-volt current, 120 milliamps. So I'd have to current limit that for sure. I wonder if the electromagnetic interference from the coil being so close to this would do anything to it. I don't know. Alright, so I can't exactly explore this today, but pretty soon we might actually try that out. The other thing that I was thinking about was how stepper motors work in the first place. They have a series of fixed magnets, and then they've got a coil that works as an electromagnet, and they switch polarities. Well, they have two sets of coils, two coils, and they'll energize the coil with reversing polarity, which changes the polarity of the magnet. And then the fixed magnets either are attracted to or repelled by each one of those coils. So if you do them in the right order, it makes the thing spin. It occurred to me that I might be able to do exactly that with this kind of a setup. That if I created a couple of very small coils with a whole bunch of turns on it, and then built a disc with a series of magnets. Here, I'll do this to illustrate what I'm talking about. I won't get rid of those. Okay. Capture, yeah, fine, whatever. So if we had this, then imagine. Let me get some reference lines in here. Let's see, let's 4 millimeters, whatever. Those can be any size magnets that we want. So if we set up a series of magnets, let's do, I don't know, 12, 16, there. If we had a series of magnets here, and then we had, if they were, I don't know if they need to be reverse polarity each time. When I was going over this in my head, I was thinking that they could be reverse, well, whoops. Each one of them would be, every other one would be the opposite polarity of its neighbors. Does that make sense? And then the idea would be if I had two coils, one of which was offset from center, then basically the way that I was thinking about this is that let's say that if I energize this coil and it's the same polarity as this magnet, then it will repel this magnet. Okay, let me this is the other state. Okay, if this coil is off, sorry about that, if this coil is off and I energize this one, and these have opposite, these magnets here have opposite polarity, then this coil is going to pull one of these two towards it. And yeah, let me extrude this out real quick. Because that way I can, let's give this an arrow as well. We can do on line. I'm fairly certain this would work. What I'm most worried about is whether or not I can build a coil that's strong enough to do this. So let's also... What is this? Let me hide this, and we'll do every others. Jeez. There we go. Oh, yeah, okay. I didn't see that, and I suddenly thought that 16 was odd. Actually, I didn't even have to do that, did I? I could have just extruded all of them. Oh, well. Okay, turn that one back on. And let's do, I guess, red for positive. Or, well, red for one of them. We're going to swap them in a second. And blue. The other ones. Actually, can I... Okay, that's better. Let's hide that, and let me... let me go ahead and let me do it this way. I'll create a couple of subcomponents for this just so that we can move them around. Well, A. Oh, sorry. If you can't fit a servo inside a pop bumper body, you may be able to have a shaft come through and drive it with a motor mounted away from the pop bumper. That's a possibility, Toyota Boy, or not even use a servo. There are small motors that would fit. I know of one that runs off 5 volts. Yeah, I have a few of them coming in that should be here tomorrow, apparently, that are just super duper small. Let's see. Boy, that is small. 300 RPM. Cool. Yeah, that could work. The thing that I worry about is there is precious little space in here. I guess what you might be able to do is have the shaft come down here with a gear and then pull it off to the side. That's a possibility. But I don't think that there's enough room to actually mount a shaft in here. The other thing to consider is that if you don't use these existing holes in some capacity, well, 2 of these are for holding the pop bumper down. So these 2 allow the wires to come up for the light, the lamp on the inside. So you'd have to, if you wanted to direct mount the thing in there, it would have to fit in this space, which is probably a pretty tall order. And in fact, it's probably going to be pretty challenging even just putting a gear in there and then having a belt come out to, somewhere else here-ish. That's a possibility. It may be something to look at. I'm encouraged by this idea of I have that 6-volt motor modeled if you want me to send it. Oh, yeah, I guess so. Or I could actually just purchase one. I really enjoy doing this modeling stuff. It would be fun to just grab that to do, honestly. Here, let me add it to my list. And in fact, I love this page because it's got all kinds of variants with different gearings on it and stuff. So I may pick some of those up just because. All right, let's see. Make another one of these. Oh, we probably want to paste new for this. Paste new. There we go. And we'll give that, let's say that's green. Okay, so so this is what I'm thinking. Like, if we had this set up where you had these two coils and they were offset like this, oh, of course, now this is gonna, jeez. Okay, hold on. I was gonna rotate this whole thing, but I realized that it's all parented, so everything would rotate. Just call it ring. And we want to take all of this and move it into there. There. Okay. All right. Anyway, what I was saying was that if you had this kind of a setup where you've got one coil that we'll say is currently attracting red and the other one is off, then you could turn yellow off and turn green on, attracting either of them. Blue, we'll say. So when that happens, then this would rotate to that position, right? And then quickly you turn green off and turn yellow on to attract blue, and that gives you that position. Then you turn yellow off and turn green to attract red, and that gives you that. And then green off and yellow to attract red. So my thought is that you could, with two coils, you could actually turn it as much as you wanted to. And in this kind of a setup, we would need two coils on either side of the pop bumper here. So like if we could put one here and one here, then we'd have this ring of magnets around the whole thing with differing polarities, and that ring would basically just be on a bearing with a mount and screwed directly into the pop bumper body. I like this idea because there's lots of throw that motor in the assembly. Okay. Let me grab it. I have a grab. Why is this not letting me do this? Oh, I'm not logged in. That would do it. Sign in. Yep. Where am I going to throw this? Storage models. That sounds good. Waiting for my hard drive to spin up. Okay, and send a zip. Okay, and let me throw this in third party. I thought that did I get rid of that? I guess I must, or did I call it external? Okay, well, whatever. I'll throw it in electronics. Upload. Ugh. I don't know. Like I said before, there's potentially a reason why nobody has done this yet, because it's difficult to do. Because it seems like a really basic thing that I would imagine a lot of tables would benefit from. Oh wow, that is tiny. Let's see. It's odd. Right, what just happened here? Oh well, first of all, I didn't. Yeah, okay. Didn't parent it correctly. That is indeed small. Is this your model, Toyo Boy? I forgot to notice. Or I didn't notice. Is this your... It looks good. Okay, let's see. Where might we put this? Well, yeah. So, no, just found a copy. Okay. Well, remember the play field is basically right here. Let's see, do I have that? Okay, well, this is the milling geometry, meaning this is the geometry to remove from the play field to make this mount. Yeah. So I guess these are the screw holes. Yep, that makes sense. Should fit inside body. I don't think so. I think it's still too big. Oh, that's not what I want for sure. Okay. Let's see. What's our... We can do this because it's fancy. Section analysis. That's what I want. And we want it on that plane. There we go. Holy crap, that is freaking amazing that fits. Wow, good call, dude. And if you did that, you could center it. Right? So you need to make a custom pop cap that goes a little high. Yeah, for sure. Potentially, here, let me actually align this properly. Turn that off. Hold on. So we want to align that with the actual center of everything. Yeah, let's turn the analysis back on. They make LED rings for pop bumpers too, so you don't need to run a bulb in the center. That's also a good point. Dude, this is excellent. Thank you for the suggestion. Yeah, that's doable. That is going to be a little bit high, but I think that that's probably okay. If that was sitting there, does that whole thing fit? My God, that's a tiny motor. All right, so given that, well, let's see. What's 300 RPM? Um, it's only 6-volt motor because it has gears. You get torque. Sell it in any RPM that you want. They're cheap too. Yeah, you're not kidding. I see that they have it in 3, 6, and 12 as well. Uh, potentially, potentially the 12 would be the way to go, just because we already have that voltage being supplied all over a table, right? Um, but either way, my original intent was also to build a small microcontroller board that would control this. Basically, that um, you could either take an input directly from the spoon switch, or I mean, there are a few ways you could do it. If you could get it from the board, the controller through a logic pin, that would probably be ideal. But potentially, you could even snoop when this coil fires. I for a while was thinking about, could you do it somehow mechanically, and that's still a possibility, I think. Let me grab a switch again. Um, the arm on this thing isn't going to be right, but it'll give you an idea of what I'm talking about. If they make even smaller sub-micros than this, but let's see if this fits. Yeah, that might be pushing it. God, I cannot believe how small that motor is. That's incredible. Yeah. So I guess that's not going to work. That's going to be too high. My thinking with this was that if I had a switch here, then you could bend this arm down essentially so that it's the so basically when the yoke is pulled down, is this called the yoke? I forget what this is. It's this thing. When this thing gets pulled down, that it would open the switch. Having something detecting being pushed down when this fires would almost certainly be catastrophic, because you've got all of this coil power pulling down on it. Some people run those motors off insert lamps. Oh, so it runs in certain modes. That's a good idea. Holy crap. Okay. Well, I wish I hadn't ordered all that other stuff to try, because I'm pretty sure you just solved the problem, Toyota boy. Good job. We'll have to. I wish I had channel rewards to to gift you, but we're getting close. We're one away. We get one more follow. I'll be back with affiliate status, and I'll have to come up with some emotes. I'm thinking about doing a Bally brick and maybe a pop bumper drawing, or electronics or something. I'm not sure. I don't know, but we'll make it fun. Okay. Well, I think I'm gonna go ahead and call it. I'm starting to get pretty tired. I am super excited by this prospect, though. So, I think as soon as I'm done with this, I'm gonna go ahead and order one of these guys and give it a shot. So, appreciate you stopping by. It's always good to see you. Um, you know, please come on back, and if you guys ever have any suggestions as to what you'd want to see, or what you want to try or explore or whatever, please let me know. Amazon $6. If you order AliExpress, they're like $1, but you have to wait a month. Yeah, I've ordered some stuff from AliExpress, and you're right, it is cheap. And it's the same stuff, obviously. They're made in the same factory, but
You're sort of at the mercy of whenever the ship gets here from overseas. So I don't mind. I don't mind paying that extra little bit for this. Now, if I was doing it in bulk, then that might be something else. But okay. Well, I guess let's find somebody to raid. Okay. Let's raid Mutterfutter. Mutterfutter is good peeps. Again, thanks for stopping by, Toyota Boy. That is so difficult for me to say, but I'll get it eventually. Alright, well, appreciate it. I'll see you guys in the next one. Not sure what we're going to do, but we'll figure it out. So, alright, take care. See ya.